Good afternoon, everyone. My name is G. Marte, and again, here we are talking about what is trigonometric functions in reducing power identities. So first, what is the power reducing identities? So power reducing identities are a useful set of trigonometric formulas that simplify expressions involving trigonometric functions raised to higher powers. So the power reducing identities are very helpful in calculus, where simplifying trigonometric power is necessary. So, in power reducing identities, the formula can be used to derive some equations so that we can solve it easily. So, this can be helpful in calculus because in calculus there are a lot of derivation that will be tackling in the lesson. So, first, how can we derive sine and cosine? So this is the formula of them. Functions in power reducing formula. Now I'll give you some exercise and example on how can we use it in how can we answer the questions using the power reducing formulas in cosine and sine. In tangent, there are also a power reducing formula in tangent. However, I will not explain how to solve it because I am focusing only on sine and cosine. So now I'll give you some examples first and then assessment after that. Here we have first example of power reducing formula on sine. So we have simplify sine squared 30 degrees. So first we identify the question. So we can say that x equals to 30 degrees or theta equals to 30 degrees. And then you can substitute to sine squared 30 degrees equals to 1 minus cosine 2 multiplied by 30 degrees over 2. So simplify the cosine. So we simplify the cosine by cosine 2 multiplied by 30 degrees equals to cosine 60 degrees. So 60 degrees in unit circle or in calculator, we can say that cosine 60 degrees is 1/2. So substitute, so sine squared 30 degrees equals to 1 minus 1/2 over 2. Simplify sine squared 30 degrees equals to 1/2 over 2 equals to 1/4. So the answer of sine squared 30 degrees is equal to 1/4. So in example number 2, we have sine squared 45 degrees. So first, let's write the formula. So sine squared theta equals to 1 minus cosine 2 theta over 2. So theta is equals to 45 degrees. So substitute. So 1 minus cosine 2 multiplied by 45 degrees over 2. And then we can simplify that. So since cosine 90 degrees is equals to 0, we can say that 1 minus 0 over 2 is equals to 1/2. So the answer is sine squared 45 degrees is equal to 1/2. So in example number 4 is simplify sine squared pi over 6. So theta is equals to pi over 6. So sine squared theta is equals to 1 minus cosine 2, substitute pi over 6 over 2. And then simplify 2 multiplied by pi over 6 equals to pi over 3. So find cosine pi over 3. We can say that pi over 3 using calculator or unit circle is equals to 1/2. So back to the formula, sine squared pi over 6 is equals to 1 minus 1/2 over 2. So simplify sine squared pi over 6 is equals to 1/2 over 2 equals 1/4. So the answer is sine squared pi over 6 equals 1/4. So we have another example number 4. So simplify sine squared pi over 4. So number 1, identify theta is equals to pi over 4. And then substitute, so sine squared pi over 4 equals to 1 minus cosine 2 multiplied by pi over 4 over 2. So simplify 2 pi over 4. So simplify 2 and pi over 4. So 2 multiplied by pi over 4 is equals to pi over 2. So find cosine pi over 2. So cosine pi over 2 is equals to 0. So number 4, sine squared pi over 4 equals to 1 minus 0 over 2. So equal to 1 over 2. So the answer of sine squared pi over 4 is 1. Have some exercise. So exercise have already an answer. So cosine squared in 60 degrees equals to 1/4. So sine squared 30 degrees is equals to 1/4. Sine squared 60 degrees is 3/4. And then cosine squared 30 degrees is equals to 3/4. Sine squared is pi over 3 equals to 3/4. And then cosine squared pi over 3 is equals to 1/4. So power reducing formula is easy and can be solved using calculator or even without calculator. So just be mindful of your substitution and your method of simplifying. So that's all. So example number 5 is simplify cosine squared pi over 6. So theta is equals to pi over 6. So cosine squared pi over 6 equal, so write the formula. So 1 plus cosine 2 multiplied by pi over 6 over 2. So simplify 2 pi over 6. So 2 pi over 6, 2 multiplied by pi over 6 is pi over 3. So let's find pi over 3. So cosine pi over 3 is equivalent to 1/2. So again, write the formula and substitute. So it equals to 1 plus 1/2 over 2. So simplify, we can get that 3 over 2 divided by 2 is equals to 3/4. So cosine squared pi over 6 is equals to 3/4. So next example number 6. So cosine squared pi over 4. So simplify and then identify theta. So theta is pi over 4. So again, substitute theta into pi over 4 and then simplify the cosine 2, and 2 multiplied by pi over 4 is equals to pi over 2. So cosine pi over 2 is equals to 0. Then substitute and add, simplify 1/2. So the answer of cosine squared pi over 2 is equals to 1/2. So next is number 7, example 7, cosine squared 30 degrees. So theta is equals to 30 degrees. So again, substitute theta into 30 degrees. So simplify, 2 multiplied by 30 degrees is equals to 60 degrees. So substitute 60 degrees to the formula. We can get 1/2. So again, just like what we did earlier, so cosine 30 degrees equals to 1/2 plus 1 plus 1/2 over 2. So simplify, 30 degrees equals 3 over 2 divide 2 equals 3/4. So cosine 30 degrees is equals to 3/4. So final example. So final example is example number 8. So simplify cosine squared in 45 degrees. So 0 is equals to 45 degrees. That's what we did in earlier last example. So same, substitute, simplify the cosine. So 2 multiplied by 45 equals to 90. And then cosine 90 is 0. Then substitute, 1 plus 0 over 2 is equals to 1/2. And then simplify, we can get cosine squared 45 degrees is equals to 1/2. Very good! Your answers was correct. By answering the assessment on power reducing formulas in trigonometric functions, we can say that power reducing formulas of sine and cosine are easy. However, there are also a power reducing formula on tangent, but we are going only to focus on sine and cosine. Now we can say that power reducing formula on sine and cosine is easy and can be solved by using or without calculator. This can be helpful in the future class of calculus, where in calculus there are a lot of derivation that we can use so that our mind is refreshed in the next coming years. So thank you and good luck everyone.